So it says let f, capital F, be equal to something. A lot of times they'll use g of x or h of x as this function that's defined by integral. But part of the annoyance of this problem is that we're using f and f, one capital, one lowercase. Okay, where the graph of f is above, lowercase f is above, and remember, you guys can see it right now on your paper, obviously. It kind of goes something like this, right? Okay, so this is f over here, right? And they might say f of x, or they might say y equals f of x, okay? And they might say something is equal to antiderivative of y. Just kind of go with it. Now, complete the chart below. And they did say it's a quarter circle. This is a quarter circle right here, and the area between would be the quarter circle minus this rectangle, subtracted from that rectangle, I should say. Okay, and they say they give you a chart, f of x, and they give you what? 0, 1, 2, 3, right? All right, let's look at f of x when x equals 0. Okay, if x is 0, that means capital F of 0 equals, and then we just put 0 in everywhere we see an x. 0 to 0, and you see why we use different variables? Because now we don't put a 0 in, right? It's f of t. Now, what does this stand for? What is it? What is it? Integral? It's 0? No matter what? But what does it stand for, though? How would you calculate this? I know you don't have to because it's 0, right? But what does this stand for? Yeah, entering a curve from here of this, right? Okay, so this is 0, obviously, right? Now, what would number 1 be then? Or actually 1, I should say, not number 1. And that would be antiderivative 0 to 1, f of t dt. And what is this? What does this stand for? It stands for the area under the curve from 0 to 1, right? So capital F of 1 is calculated by finding the area under the curve of lowercase f from 0 to 1. And that looks like it would be like this. Is that a rectangle? Yeah, it'd be a rectangle. Width of 1, height of 2, correct? So that'd be 2, I believe, right? Okay, and so on and so forth. Okay, all the way up to 8, guys. And if you want to break this up and find those areas, like find this area, because you're going to add them all together as you go. Okay, they skipped 6. The reason why 6 would be right here, and you have good luck finding that area. Okay, and remember this little area, if I draw it, maybe like magnify it a little bit. So this is the area between the curve and the x-axis, right? Well, you have to take this square and subtract out this quarter circle to find that area, correct? So keep that in mind and do it geometrically. Use the geometric formula, okay? Questions on the capital F part. Okay, now we have to find capital F prime. Well, what does capital F prime equal? Well, if you take the derivative of this side, what do you got to do? Take the derivative of this side. And what is this? What fundamental theorem is this? The second fundamental theorem, the derivative of the antiderivative, right? And what did we learn to do yesterday? If it's just x, what do? It's the easiest problem we've ever done in calculus, right? Substitute. That's f of x. So that means f prime, folks, is just equal to f of x. And capital F prime, you get what I'm saying. Okay, you can see it. So we have a chart 0, 1, 2, 3, 4. So capital F prime of 0 equals f of 0. What is f of 0? And what does this stand for? 2. The answer is 2, but what does it stand for? The height of the graph, right? So capital F prime is the height of graph f at x equals 0. Okay, so let's go f prime of 1 then. That would be f of 1. What is equal to? 2 again. So what is f prime of 2? It looks like about 1, right? Does that make sense? So, major calculus idea, this right here, which gives us this. And again, this is going to be a pretty easy problem because all it is the heights at those different values in the graph, okay? AP test, a lot of times they'll say this is g of x, and they'll say what's g prime of 4? Okay. Now, part B, it says on what subintervals of, inclusive 0 to 8 is f increasing? Guys, if we want to know when f is increasing, we've done this before. What do you look at? When is f prime greater than 0, correct? And what is f prime? It's right here, guys. F prime is equal to f. So we want to know when f is greater than 0. Well, look at your graph. When is f greater than 0? And be careful of this one because this one is equal to 0, isn't it? So exclude that one, please. So 0 to what? 0 to 3, and then what? 3 to 5. That's it. That'd be intervals when the f of the function is increasing. Okay. When it says when is f decreasing? Well, capital F is decreasing when capital F prime is less than 0, and we know the relationship of that is true. So f is less than 0. When is f less than 0? Whatever this value is to this value, to 8, correct? And we're using parentheses, please. Does that help? Okay. I think sometimes this connection is not so obvious, but use your intuition. If we have capital F and they want us to find what f prime is, take the derivative of the other side. Well, that looks familiar. We just did that. We just learned that. Okay, and that's why it's on this worksheet. Okay, justify your answer. Well, aren't these the justifications? I like to include both. Okay, where on the interval, this is part C, by the way, 0 to 8, does capital F achieve a minimum value? Well, how do we find minimums? What do? Find out when this equals 0, and then use those values test on your table. Okay, so then you go back. Okay, if f prime equals 0, and then that would be what was that? 1, 2. That's 3 and 5, correct? So 3 and 5 are our critical numbers, correct? And then include the endpoints, 0, 3, 5, 8. Okay. Now we substitute those back into f, correct? So let's substitute those back into f. F is defined by antiderivative, and you actually already have these values. F of 0 equals antiderivative 0 to 0 f of t dt. And what's this value? 0. F of 3. Antiderivative 0, 3 f of t dt. Well, you have that value up here in the chart, don't you? Okay, use those values. Okay, the biggest one will be your max, the smallest one will be your minimum. Okay, justify your answer. Remember, when we find absolutes, or when they say minimum, thank you, I didn't catch that right away. Justify your answer, that's just your candidates test. And you don't need to do 2 candidates tests for both parts C and D. It's right, we understand that. Okay? And where should the max be? If capital F is the accumulation of area, where should the maximum be? If you start here at 0, you haven't accumulated any area, correct? Now, as you go this way on the x-axis, what's happening? You're adding area, right? Adding area, adding area, adding area. Whoop. Now I'm going to add some more area, more area, more area. And then we stop adding area right here, and we start subtracting area. So where should your maximum be? Should be right here, right? Then now the difference is, where is the minimum? Is it at the beginning? Or do you have less here? Do you take all of that away? Okay, that's something you guys will have to figure out. All right, find the concavity Okay, concavity for capital F. Well, we need to find capital F double prime. And what does capital F double prime equal? Well, it's equal to F prime. Where is F prime equal to 0 or undefined? Well, look at your graph. This is the graph of F. Where is F prime undefined? It's undefined a whole bunch right here. Right here, right here, right here, right here, right here, correct? So those are possible points of inflection. Okay? And while you're finding the possible points of inflection, you can note the concavity also. Okay? Now, what is F double prime from 0 to 1? What's the slope of the tangent line of F? Right here, 0. It's neither positive nor negative. What's the slope of the tangent line here? That'd be negative. So you're concave down. Slope of the tangent line here, positive, concave up. Slope of the tangent line here, negative. Slope of the tangent line here, negative. Slope of the tangent line here, negative. So you can adjust your concavity that way. Okay? Does that make sense? Does that help out? Yeah? All right. Then sketch a rough graph of capital F. Well, don't you have a whole bunch of points for capital F up in your table up here? Plot those points, connect the dots. See what you can come up with. Tomorrow or even after this class, or maybe even towards the end, I might post the answer key to this. You guys can kind of check some work, okay?